Hello students, in our today's video lecture we are going to discuss about air conditioners and refrigerators. A typical person in modern society may spend up to 90% of each day indoors. It is not surprising therefore that providing a healthy, comfortable indoor environment has become a major factor in our economy. To an average person, air conditioning simply means the cooling of air. This definition is neither sufficient, useful, nor accurate. To be more precise, air conditioning is the process of treating air in an internal environment to establish and maintain required standard of temperature, humidity, cleanliness, and motion. Most air conditioning systems are used for either human comfort or for process control. Air conditioning is the process of treating air in an internal environment to establish and maintain the required standard of temperature, humidity, cleanliness, and motion. That is what I have said. So this is how each of these conditions is controlled. First is nothing but of temperature. The air temperature is controlled by heating or cooling the air. Cooling typically means the removal of heat in contrast to heating, the addition of heat. Next comes the humidity. Air humidity. The water vapor content of the air is controlled by adding or removing water vapors from the air. Then cleanliness. Air cleanliness or air quality is controlled by either filtration, the removal of undesirable contaminants using filters or other devices, or by ventilation, the introduction of outside air into the space which dilutes the concentration of contaminants. Often, both filtration and ventilation are used in an insulation. Finally, the motion. Air motion refers to air velocity and to where the air is distributed. It is controlled by the appropriate air distributing equipment. Sound control can be considered an auxiliary function of an air-conditioned system, even though the system itself may be the cause of the problem. The air conditioning equipment may produce excessive noise requiring additional sound attenuation devices as part of the equipment. The description what I have told does not imply that every heating, ventilation and air conditioning system regulates all of the conditions described. A hot water or steam heating system consists of a boiler, piping and radiating device only control air temperature and only during the heating season. These types of systems are common in many individual homes, apartment houses and industrial buildings. A warm air system consists of a furnace, duct and air outlet register. Also controls air temperature in winter only. However, by the addition of humidifier in the duct, it may also control humidity in winter. Warm air systems are popular in residents. Some residents have combination of air heating and air cooling equipment that provides control of temperature and humidity in both winter and summer. Some degree of control of air quality and motion is provided in airtight heating and cooling systems. Air conditioned system used for newer commercial and institutional building and luxury apartment houses usually provide year-round control of most or all of the air condition described. For this reason, it is becoming increasingly popular to call complete HVAC system environmental control systems. Most air conditioning systems are used for either human comfort or for process control. Air conditioning enhances our comfort. Certain range of air temperature, humidity, cleanliness and motion are comfortable, other are not. Let us discuss about the components of air conditioning system. Heat always travels from a warmer to a cooler area. In winter, there is a continual heat loss from a building to outdoor. If the air is in the building is to be maintained at a comfortable temperature, heat must be continuously supplied to the air in the rooms. The equipment that furnishes the heat required is called a heating system. In summer, heat continually enters the building from the outside. In order to maintain the room air at a comfortable temperature, this excess heat must be continuously removed from the room. The equipment that removes the excess heat is called a cooling system. An air conditioning system may provide heating, cooling, or both. Its size and complexity may range from a single space heater or a window unit for a small room to a huge system for a building complex. Most heating and cooling systems must have the following basic component: a heating source that adds heat to a fluid that can be of air, water, or steam. A cooling source that removes heat from fluid, that is air or water. A distribution system, the distribution system is nothing but of a network of duct or piping to carry the fluid to the room to be heated or cooled, and the equipment for moving the air to water. Finally, the device for transferring heat between the fluid and the room. Let us first discuss about the all-water air conditioning system. A typical hydronic all-water heating system is shown in this figure. Water is heated at the heat source. Water is heated at the heat source, usually a hot water boiler. The heated water is circulated by the pump and travels to each room through the piping and enters a terminal unit. The room air is heated by bringing it into contact with the terminal unit. Since the water loses some of its heat to the room, it must return to the heat source to be reheated. If steam is used as a heating system, the component still works in the same manner, with the exception that a pump is not necessary to move the steam. The pressure of the steam accompanies this. However, when the steam cools at the terminal unit, it condenses into water and may require a condensation pump to return the water to be boiler. A hydronic cooling system as shown here. Its function is in a similar manner to the hydronic heating system. The water is cooled in refrigeration equipment called a water chiller. The chilled water is circulated by a pump and travels to each room through piping and enters a terminal unit. The warm room air loses its heat to the cold water in the terminal unit. Since the water is now warmed, it must return to water chiller to be recooled. Hydraulic systems are popular that requires both heating and cooling. This is because it is possible to use the same piping system for both by connecting a hot water boiler and water chiller in parallel, and that is being shown in this figure. Next we will discuss about all air conditioning unit. All air system uses air to heat or cool rooms. They may also have the added capability of controlling humidity and furnishing outdoor ventilations, which hydronic system cannot do. A typical all air heating and cooling system is shown in the figure. Air is heated at the heat source such as furnace, that is here. Then it is being traveling to each room through a air supply duct. Then the supply air enters the room through the outlet called air diffuser or register that are designed to be provided proper air distribution in the room. When the warmed supply air enters the room is heated. A humidifier may also be included to maintain a comfortable room humidity in winter. In summer, air is cooled when it flows over a cooling source, usually a coil of tubing containing a fluid cooled by the refrigeration equipment. When the cooled supply air enters the room is cooled. Because a room size is fixed, the same volume of air that enters the room must also exit. This is usually accomplished by return air duct. The air is then heated or cooled against the recirculated one. An outdoor air intake duct may be provided for introducing fresh outdoor air for increasing air quality. Similarly, the same volume of air must be exhausted. Provision may be made for cleaning the air with the air filter and for humidifying the air. A refrigerator system extracts heat from a substance at a temperature lower than the ambient and transfers the extracted heat to the atmosphere at a temperature higher than the ambient. A refrigerator system is termed as a heat recovery system when its refrigeration effect is utilized for cooling an area or fluid and the heat rejection is put to some beneficial use. A heat pump, when it is used for cooling during summer and heating in a winter by incorporating suitable accessories for the changeover from cooling to heating mode and vice versa. Food preservation, both for processing and storing, is one of the significant applications of refrigeration. Food process calls for chilling, freezing, quick freezing, or freeze drying. Typical applications are the domestic refrigerator and home freezers, ice cream manufacturing and storage, drinking water coolers, beverage cooling, cold storage, process cooling of meat, fish, dairy products, fruits, vegetables, transport, refrigerations, etc. A schematic flow diagram shows the basic component of evaporation of compression refrigeration system. To aid in understanding, some typical temperature for air conditioning applications are also indicated. Refrigerator fluid circulates through the pumping and equipment in the direction as shown in the figure. There are four processes that occurs as it flows through the system. Process 1 and 2. At point 1, the refrigerator is in the liquid state at a relatively high pressure and high temperature. It flows to 2 through a restriction called flow control device or expansion device. The refrigeration loses pressure going through the restriction. The pressure at 2 is so low that a small portion of the refrigerator flashes into a gas. But in order to vaporize, it must gain heat. When it takes from the portion of the refrigerator that did not vaporize, thus cooling the mixture and result in low temperature at point 2. Next, process 2 to 3. The refrigerator flows through a heat exchange called the evaporator. This heat exchanger has two circuits, the refrigerator circuit in one and in other the fluid to be cooled. The fluid to be cooled is at slightly higher temperature than the refrigerator. Therefore, heat is transformed to the refrigerant, producing the cooling effect desired. The refrigerant boils because of the heat it receives in the evaporator. By the time it leaves the evaporator at 4, it is completely vaporized. Process 3 to 4. Leaving the evaporator, the refrigerator is a gas at low temperature and low pressure. In order to be able to use it again to achieve the refrigerating effect continuously, it must be brought back to the condition at 1, that is a liquid at a high pressure. The first step in this process is to increase the pressure of refrigerator gas by using a compressor. Compressing the gas also results in increasing its temperature. Process 4 to 1. The refrigerator leaves the compressor as a gas at high temperature and higher pressure. In order to change it to a liquid, heat must be removed from it. This is accomplished in a heat exchanger called the condenser. The refrigerator flows through one circuit in the condenser. In the other circuit, a cooling fluid flows at a temperature lower than that of the refrigerator. Heat therefore transfers from the refrigerator to the cooling fluid, and as a result the refrigerator condenses to a liquid. This is shown in this figure. The refrigerator has returned to its initial state and is now ready to repeat the refrigeration cycle. Or, of course, the process are actually continuous as the refrigerator circulates through the system. The absorption system uses the principle that some gases will be absorbed by certain other substances. There are many pairs of substances that have the affinity for one another. We are all aware of how table salt absorbs water vapor from the air, thus making it difficult to pour. Yet another combination is the lithium bromide in water. Lithium bromide will absorb large quantity of water vapor. This pair is used in many refrigerator systems. So that's all with Unit 3, and the Consumer Electronic course comes to an end. Wish you all the best for your end semester examinations. Thank you.